Hey guys, this is Daniel with PwnCNC and I'm here to hook up my spindle kit to my VFD over PWM line over to my X-Carve. I still have my X-Carve suspended here from the ceiling. I've just lowered it so I can access it. I'm doing a quick, huge reorganization of what's going on here, so I can't actually pull it down all the way, but I can turn it on and all that stuff. So I can use it just suspended here. It'll just float around a little bit. But what I need is the PWM cable. This is going to have simple connectors, ferrule connectors on either end, as well as the latest copy of my spindle manual available on docs.pwncnc.com/spindle. If you don't already have that, get that. And we're going to walk through, I believe it is starting on page 22. I want to say. Nope. Page 19. So jump there and let's get to it. All right. Here we are with a close-up of the VFD. As you can see, I've got it turned off. There's no power going to the system, which is good because L1 and L2 are live lines if that was the case. I've already fed my PWM cable through my bottom case here. I've got a special yellow color for it, but it's running through the center channel, and I'll put a zip tie in there to hold that and tighten this back down here after I'm finished. But what I've got is a red line and a black line here. The red line is going to go into the center both wires are going into the center terminal block. The second one from the left, that is the VF1. So I'm going to loosen that. I'm also going to be putting the black line into the fourth one from the left. So I'll loosen that one as well. Then I'll work the wire around so that I can get both connectors plugged in. Again, that's red to VF1, black goes to GND or ground. So let me tighten this down. There we go. Okay, that side is done. I'm ready to put my case back on and put my cover on, and I'm ready to go. We're going to switch over to the controller side, and we'll dig into that in just a second. Okay, here I am on the back of the X-Carve controller. If you're following along in the manual, we have actually jumped over to I believe it is page 22, page 20 towards the bottom. Down there I actually detail, I give you a close-up of what this looks like, but essentially we're going to pull out this bottom terminal piece here, and that will allow me to loosen up a couple of screws. Our PWM and ground, that's the red and black line on the controller side of our VFD cable. The red and black line are going to go right there onto these far, so here it is plugged in on the far, facing it from the back on our right, here on the screen. I'm going to loosen those up. I'm also going to take advantage of the fact that there's multiple grounds on this line, and we're going to take over the second one to the end. So we're going to take that one, and we're going to send our drain shield, our shield drain down there. So on the controller side of the cable, this is a shielded cable, and the VFD side is not grounded because we don't want any electricity to pass through the shield. But we do want one side of the shield grounded. So that's what I've got, this little pigtail here, this copper pigtail. This comes straight out of the grounding, the shielding of our cable here. So the ground cable, GND, that's the far left, is going to be where the black line plugs into. So I'm going to go ahead and get that into place and tighten it down. There we go. And the red line, or the PWM signal, is going to go right into the port right next to it. Okay. Now, the last line, that's our drain, our shield drain. We're going to drop that right into that one to the far left, the second one from the end. And that will help curb any electrical interference we might be receiving during however we've got our cable run. So once you've got that all screwed together, put in, we can go ahead and press that back into place on the back of your controller. And that's it. Wiring is done. It's time to jump over to the VFD and do some programming as described on page 21 of the manual. Okay, here we are with the VFD. I've extended it with the Cat 5 cable and made it a little more comfortable for me rather than a floating platform. So I've got the VFD controller here, and it is configured so that I can manually run it from here without having to change anything over there, right here from the keypad. Now, what we want is this controlled, the frequency. Right now, if I control this, this changes the frequency that the motor would be running if I was in a running state. But what I want is not to use that. I want to use the PWM line we just wired up. So what we're going to do is on page 21, looking down at the configure VFD settings for PWM control, we're going to hit the mode button, go up to version 4, so P0.0.04, hit enter. By default, that's 2. That means where is the frequency source? Who specifies the frequency? 2 means this little dial here. 3 means the PWM line, or the VF1. So that's what we want. We want this to be set to 3. So P0.0.04 should be a value of 3. And you hit enter to make that accept it. Now, when your spindle, when you start a job, you want the spindle to spin up to speed before it moves into position and starts making contact with the stock material. So right now, the default settings is about 20 seconds. It takes about 20 seconds for it to move from a 0 RPMs all the way up to your specified setting. We want to increase that because when you program it, when you run the spindle from a program, the program expects it to run a lot faster than do what it's told, right? So we're going to change this. We're going to just hit the up arrow until we hit the P0.0.11. That's listed right here on the thing. It's basically the acceleration time. When you hit enter, that's going to be defaulted to a 20, so 20 seconds. But due to the diameter of our bits and that sort of thing, because they're not super huge or anything like that, we can go ahead and increase that so that the spindle spins up to speed within 4 seconds. So it goes from 0, let's say you said it wanted to go to 12,000. So it goes from 0 to 12,000 in 4 seconds. So that's your acceleration. Now hit enter there. And we also want to increase, speed up, it's slowing it down. We want to slow it down faster. So that's going to be P0.0.12. Hit enter. And again, this defaults to 20 seconds. So we're going to change this to 4 seconds. Hit enter. So that's accepted there. Now, we're in luck because the X-Carve provides us with a 0 to 10 volt PWM signal. Our VFD has a default setting of accepting a 0 to 10 volt signal. But just to verify, and of course it's right here listed at the bottom option, we're going to go to P2.0.15. So P2.0.15. Hit enter. It should be listed 10.00 volts. So that's the maximum input of the PWM. So therefore, when it sends a signal of 5 volts over the PWM line, the spindle is expected to run at 12,000 RPMs. But if a full 10 volts is sent across the PWM line, then the spindle is expected to go at maximum speed 400 hertz or 24,000 RPMs based on the motors that we sell here at PwnCNC. So we're going to hit enter there. Now, I do want to give you one little tip. This is another one of those extras that I keep telling you about. The more and more I research this VFD, the more awesome it becomes. One of those settings, I know some of you have mentioned if you've received some of my early ones, I've started to program this automatically, but if you go back to the programming code, and in my case, I'm running a 0.8 kilowatt motor on this one, and that's detailed. The full set of programming is detailed right there on page 7. You'll see down towards the bottom, there's a P5016. So some of you may have noticed that the RPMs, it doesn't actually show you the full RPMs. So let's say you tell it to run 6,000 RPMs. This display will actually tell you 600.0 instead of 6,000. So changing this value, P5.0.16, change that to a 0, and now it will actually show you 6,000. It will not have the decimal place in there. So you can just hit mode to go back to running state. And you'll notice because we've configured our frequency source, it no longer changes the frequency whenever I turn this dial. So this dial is basically dead now. It won't do anything. It's not useful. But your stop and run controls are still here. So what I like to do is whenever I'm running a program, I will set all my bits and everything. Whenever I go near, whenever my hand goes near the chuck at all, this thing is flashing. It gives me an indication that there is no power that will be sent to that motor. But when that is not flashing, when it is solid, and you see the run light there, when it is solid, I know I will not be touching that chuck anywhere anytime soon until I hit the stop button and force it into a dead or stopped state. So now that we've got this, I'm going to hook up my CNCJS, and we're going to turn on our controller, and let's do some controller programming. Okay, now we're going to talk about the very next stage, or I guess literally the next page of our manual here, which is page 22. This is where we've actually got the controller turned on. The CNC is active. The VFD has power, and you can see that from the flashing light here. I have got a program called CNCJS running on a Raspberry Pi that's built into this touchscreen high-resolution monitor. So it will be really hard to see what's on the screen. I will describe as I go along exactly what's going on. But most of our experience, so long as you have console access to your controller, that's where you can get in and see the Gerbil settings. Here, let me jump into it and I'll show you. So I'm going to connect over USB to my controller, which automatically spits out my $sign. I'll expand that out. Let's see if we can zoom in a little. So yeah, it's going to be really hard to see there, but I'll try to explain it here. So I'm basically just going to follow along right here on the manual. There are the Gerbil settings. These are the $sign values. If you hit $sign, it'll list out all in the console, whatever console software you happen to be using. If you can hit $sign, it'll output all of the Gerbil settings that your CNC machine is controlled. This determines the width, the depth, as well as the height of your XYZ axis, how fast the motor should run, what voltages are set to. Pretty much all of it's controlled right here. But the three inputs that we're interested in for the spindle's sake is number 30, so that's $30, $31, and $32. We'll start from the beginning. So $30, I can see on my screen, it's really hard to see, but $30 is set to 24,000 RPMs. If yours is not set to that, it needs to be changed to that. That tells the controller what the maximum RPMs of the motor that's attached, your spindle motor that's attached. So put $30 equals 24,000. 24, 1, 2, 3. Oh, I got one too many zeros. 24000, enter. So it accepted that value, and if I run a $sign again, it will output all of my settings again, and then I can verify that it's been configured correctly. The second setting we need to configure is the minimum RPMs of our motor. So we're going to specify $31 equals 0. Next, the last setting we need to do is laser mode. So this is where you're going to tell the machine that it is not in laser mode. It does not have a laser attached to the carriage, and it's a $32 is a Boolean value. So it's either going to be false for 0 or true for 1 for true. So we want a 0 because this is not in laser mode. So $32 equals 0, and that's it. Our entire setup is ready to go. We're ready to start testing. So I'm going to jump past this Onefinity Modbus information here, and we're going to look on page 24 of the manual. Down here in the automatic control section, we're going to start testing. Let's do some testing. So our motor goes from 0 to 24,000 RPMs. Our motor also goes from 0 to 400 hertz. So when it receives 0 hertz, it's going 0 RPMs. When it receives 400 hertz, it's going at 24,000 RPMs. So if you cut that in half, 200 hertz means it's going to go at 12,000 RPMs. So let's do a couple of tests. So M3 space S 12,000. M3 is basically the command that says spindle move forward and then the speed at 12,000 RPMs. So when we run that, oh, I'm sorry, I forgot to unlock it. So since I did not home my machine, I need to forcibly unlock it so that I can actually run spindle commands. There we go. M3S 12,000. There it goes. So you can see the M3S 12,000. It gave me an OK, which means it's sending half or 5 volts, since it's 0 to 5 volt or 0 to 10 volt signal, sending 5 volts to the VFD. The VFD is interpreting 5 volts as half, so it's sending half of the hertz of the motor, and the motor is rated at 400 hertz, so it's sending 200 hertz. If we change that to M3 space S 24,000, it'll jump up to 400 hertz. Now, it's only showing us the hertz here because we're not in a running state. We're in a stopped state. That's hence the flashing. It's not actually doing anything. This allows us to do some testing. If we do M5, enter, M5 is the command that says spindle stop. So it's gone down to 0 RPMs. Now, to do a live test, all we got to do is, and this is what you do whenever you're running an actual job, you'd actually run it. So it's running. So now my motor, here, let me zoom out here. Let's see if you can see that motor. It's really hard to see. It's way up there. There it is. But we can see that the RPMs is 0. So if I type in my command S3, and let's just do something smaller so we can actually talk. S6000, so M3 space S6000, and the motor spins up to 6,000 RPMs, and you can tell that based on the VFD signal. It's roughly 6,000. Now we're going to do some tuning later in a later video to make sure that gets as close to 6,000 as possible, but for woodworking and that sort of thing, if it's really close, it's perfectly fine. But now that we got that, let's go ahead and switch it up to 12,000 and see what happens. So M3 space S 12,000. and it spins up to 12,000 RPMs. And of course, M5 is a stop. So now it's running 0 RPMs. But remember, before you touch that bit, make sure you hit the stop button so that it is not in a running state and it is safe to approach the spindle. So that's it. So if you wanted to know a little bit more about CNC GIS, I'll do some little tests here. I mean, this gives you a 3D rendering of your job if you upload a G-code to it. You can see the console here. You can hook webcams up to it. I even have spindle button controls here. So if I wanted it to run 6,000 RPMs is what the setting is, hit the M3 button, and you can see that it is running at 6,000 or 1/4 or 100 hertz. And of course there's an M5 on there. All these controls are all GUI based. This is a web-based interface. Of course this is running on a Raspberry Pi, just USB connected right into the controller. So hopefully you found that interesting and informative. Hopefully you were able to follow along. If you have any questions or comments, leave them down below, or preferably reach out to support@PwnCNC.com. I have multiple people monitoring that inbox so that we can make sure we get questions answers as quickly and accurately as possible. Of course, you've got my link to the spindle manual. Got it all hooked up, and yeah, this is Daniel with PwnCNC, and remember, don't just own your CNC, dominate it.